at Alexander Ahmedabad High School and the Junior College. Welcome to a series of the lectures of Intermediate First Year Chemistry. We have started our discussion with the first chapter and the basic chapter, atomic structure. We have studied the different properties, how the scientists discovered their atomic properties and everything we have discussed in that. And the second chapter we are going to start today is classification of elements and periodicity in properties. Right? What is classification? Right? We have seen different elements. We have studied a kind of electronic configuration, its basic structure. Right? We have seen this kind of experiments and all in the previous chapter. Then, how many elements do we have? Do we have any count? Right? According to the basic present periodic table, we have almost all 114 to 113 elements. Right? There are many other elements, but they could not be placed in a particular table. Okay, that's all we'll discuss again. What is this classification? Why do we need classification? Right? As you know, classification is segregating the elements based on their properties. Right? Let us assume there are 50 members in a class. Okay, out of 50 members, if I choose some people with of 10%, 20% or more than 50% like that, if I want to segregate like that, I will make them sit from first bench to last bench. That is called classification based on their properties. Okay, and we can identify them clearly with their property, isn't it? Similarly, all the elements has to be classified in order to learn its property and actually identify the element. Is it okay? For example, let us assume one element, copper. Copper is an element. It has a metallic property, isn't it? And it is a conductor, right? And not only that, few other properties such as atomic size, ionization potential, all such things has to be defined, right? Based on this, we have to arrange them in an order. Okay, that is why we need classification. Then what is this periodicity in properties? Tell me, what do you mean by the term periodicity? Period. What do you mean by the term period? Period itself means that it repeats after a particular interval. Is it clear? He tells that there are few properties which are repeating in the next period, or else we can tell that if for example, if there are few properties in the first period, it again repeats from the first of the second period. Is it clear? What do you mean by the term period? Period is a fixed time, right, which repeats one after the other. Is it right? Which means most of the scientists observe that there is periodicity in the properties of the elements. What do you mean by the term periodicity? Tell again. Periodicity, it clearly tells that the properties are repeating after a particular interval, or else we can consider it as after some 5 elements or 8 elements. The periodicity is repeating. For example, there are 8 elements. The first element will have some property, right? After this all 8 elements, the next element will be 9th, right? This 9th element will have the similar properties of this first element, right? Again after 9, then we'll go into 17th element, 1, 9, 17. These kind of elements have similar properties. Why? Because it is repeating, or this periodic property is being similar after 8 elements. Is it clear? That is also one of the most important statement of Newland. Is it clear? Did you understand what is classification and periodicity? Fine. Why do we need classifying is? Obviously, just to study a particular element, isn't it? See here, before this discovery was done, such as by Dobereiner or some other scientist in 1800, right? In those centuries, they used to have only some 30 to 35 elements. Within a decade, or else within by 1865, I think, there were almost all more than 100 elements, or almost about 100 elements. Now, if we observe, there are more than hundreds of elements, right? Then these many elements have different applications, right? If we consider a particular mercury, it have its application in different fields. Not only in the temperature measuring, it has many applications in conducting, heating kind of things, isn't it? Or else let us assume gold, right? Gold is an element, it is a good conductor, right? it is a shining element, it is a decorative element, isn't it? Not only that, in most of the electronic device, gold is a common conductor, isn't it? These many applications for a particular element, then how to study? How to place these elements in a particular order, right? In order to study the unique feature of an element, classification is needed. Okay, then who are the scientists who try to classify? There are many scientists, there are innumerous people, many people, not only in the outside of India, there are many scientists even today in India who are trying to classify elements and build a particular format so that they can arrange all the elements. Fine. See here, among them, Dobereiner was the first person. Who is this Dobereiner? Dobereiner is one of the scientists who tried to arrange all the elements in those ages, right, according to the property. How did he arrange? He tells that whatever the elements are, how many may be the elements, he tells that all the elements can be formed as 3 sets. 3 sets, whereas the average of atomic masses of the first and third element will be the second one. He tells the popular example, that is LINAC, L-I-N-A-K. Okay, he always calculated experimentally. Potassium atomic mass is 39, lithium atomic mass is 7, sodium atomic mass is 23. According to Dobereiner, the average of the first and third element, average in the sense, I have to add these both and divide by 2. What is 39 plus 7? 46 divided by 2. Isn't it 23? Isn't it? Are we getting it or not? Then this can be a fixed element. I mean fixed set of elements which have a similar properties. Once again, let me tell. Law of trade. This is particularly called as a trade. What do you mean by the trade? A trade is a group of chemical elements, right? See here, LINAK is a group of 3 elements, right? He states that the average of atomic masses of the first and third element is the second element, right? He specifies 2 to 3 sets of elements, and he also studied beautiful properties, but he was the first person to initiate it, isn't it? Fine. And after that, there is one more scientist, that is Newland. He studied the classification in 1865 as law of octaves. Have you heard about octaves? Right? Do we know the word octave? Yes or no? Do we? No, actually we don't use the octave, but octaves are the popularly word used in music. That is simply called as octave music. Hope you would have heard about those 8 elements, right? Sa, Re, Ga, Ma, Pa, Da, Ni, Sa. Isn't it? There are 8 elements in that, right? It starts from Sa, it ends with Sa. Isn't it? Which means the first and the 8th element is similar, right? Based on that analogy, Newland discovered law of octaves. He defines that as we see in the octaves music and the elements also, we can find the first element is similar to the 8th element. That means the first element will have almost all the similar properties as it have in the 8th element, and again it repeats. Is it clear? Did you understand? That's what Newland was trying to tell, right? And the next 2 more scientists, there are different experiments are being done. Most of the people, they tell that Dobereiner was good, Newland was good, but nothing was showed by that time, because by 1865 almost a few elements were discovered, some in 60s kind of elements, right? After that, Mendeleev and Meyer. Who was this Mendeleev and Meyer? They were 2 scientists who were trying to define a periodic law, right? They defined a periodic law as the properties of the elements are the periodic functions of their atomic weights, right? What is atomic weight? Atomic weight is an experimentally calculated value, isn't it? We can find the weight of it, right? Fine. Atomic weight or atomic mass is always same. Don't get confused, isn't it? See here, once again let me tell. The properties of the elements, that is whatever the elements are there, they'll have the properties which are periodic functions. Periodic functions is again the same thing. From the first thing, after it will go again with the next period. For example, let us assume I have a table like this, 1, 2, 3 like that. The element here will be having similar properties of the element here, right? If I assume this whole thing as the same period and this whole thing as the same period, the periods with the first elements have same properties. Is it right? Not only that, among these both people, Mendeleev was the first person who used the term period, right? Who gave the term periodic table, right? Before that, there were many scientists who could use the word periodicity or kind of thing, but Mendeleev was the first person who arranged the elements in type of a table, right? Now, Mendeleev discovered a particular periodic table in which there were many elements, so that he arranged everything in terms of a periods and a group, right? He divided the whole rectangular table into number of periods and number of groups. Okay, what is the period? A period is a horizontal arrangement of elements. A group is a vertical arrangement of elements, right? He placed all the elements based on their atomic weight. See here, right? And not only that, Mendeleev is the only person who could realize all the elements in terms of arrangement of a fixed table, right? See here, he arranged based on the atomic weights. Like as atomic weights are increasing, he arranged from left to right, right? And there are few elements, if you remember, there are few elements which will have same kind of atom mass, okay, same kind of atomic mass. What is done then? He placed the two atoms with the same, two elements with the same atomic mass in the same position. Then most of the scientists, they could not realize that those two elements have the same properties, but there were a few other defects. Not only this, there are few other defects, such as he did not leave place for the future elements for the first time. Then he named or he gave the future elements as, for example, if it is silicon is the present element which is available, then the next future element which has the similar properties of silicon, he named it as Eka silicon. Okay, that is nothing but our present germanium, right? After silicon, the same atom or the same element or the element with the same properties of the silicon, he predicted and he gave the name as Eka silicon. Is it clear? That's what he discovered, and he arranged the whole periodic table into number of periods and groups. That is the main thing you have to remember. And the final thing is Moseley, right? He is a scientist who gave modern periodic law. The modern periodic law, actually it was being discovered in 1913. The whole modern periodic law was based on only atomic numbers. Is it right? He didn't use any atomic mass or so on so things, right? Till now, not only law of Trids or law of octaves or the periodic law, most of the people till before 1913s, everyone were using only atomic mass as a basic criteria to construct the periodic table. After Moseley, most of the people started using atomic numbers, right? He arranged in a basic proper way, right? Till now we can't say that there is the final periodic table, but this is usually called as a modern periodic table, and mostly that is a long form of periodic table. Why it is called as long form, everything we'll discuss again, but just try to appreciate the effort of the Moseley. Because after Moseley, there are many infinite number of periodic tables were discovered. Some people, they use the helix as a periodic table. They discovered, they designed the periodic table like that. They arranged the elements in such way, right? They on a particular physical or chemical property, they used as the property of the element is high in this particular position and very low in the at the bottom. That's why the helix is being reducing to almost all 0. Isn't it? That's how there are many things. There are few people who used spherical periodic table, right? Those are a part of your syllabus, but as of now, you have to remember these are the basic periodic tables. Among them, Once again, see here, Dobereiner is the first person who used the law of trades, that he took three elements as a trade, and he gave a statement that the middle element or the second element's atomic mass is average of the first and the third element's atomic mass. Is it clear? And after that, Newland was the second person. He tells that if I consider a set of elements in which I will consider 8 elements as a set, in which the first element is similar to the 8th element. Is it clear? That's what he was encouraging, the law of octaves, right? After that, when it comes to Mendeleev and Meyer, they gave a periodic law, which means all the properties of elements are periodic functions of atomic mass, right? That means all the elements, whatever arrangement we do, the whole thing depends upon only the atomic mass, how it varies. Okay, and finally, Moseley is a person who gave modern periodic table, right? It can also be called as a simplified version of this periodic table, that is Mendeleev's periodic table. Did you understand? See here, Moseley's modern periodic table can be called as a simplified version of Mendeleev's periodic table, because he was the first person who used to coin the terms groups and periods, right? Here, Moseley is a person who used the same terms, number of periods, number of groups and everything, but he arranged based on the atomic number, right? Fine. Is it clear? See here, till now most of the people were doing only atomic mass. Then why did Moseley use the atomic number? Why not atomic mass? That is, see here, in those days there are different techniques to measure a particular atom or its structure or its surface kind of thing. Among them, X-ray spectroscopy one of the most important instrument or a technique to measure the atom surface or morphology or kind of things. In that, he observed one thing, that is the frequency, that is frequency of element or the radiation of a particular element is always proportional to atomic number, right? Just he plotted square root of nu to z and square root of nu with atomic mass. Then he found that this frequency or the square root of frequency is always a straight line with respect to the atomic number, but that is not a straight line with respect to the atomic mass, right? This is where he could realize that atomic number might be the suitable thing to arrange or to define a particular element. Is it right? Yes or no? Then what about the one more thing, that is future element prediction, how to use it, right? And before going to that, remember Mendeleev periodic table has 2 or more elements in a particular column or in a box. Then what about this Moseley periodic table? He did not use any 2 or 3 elements in a fixed box. He used only one element, right? He arranged based on its atomic number, right? And one more thing is, for example, if there are few more elements which are to be guessed in the future, then he gave complete up to 118, I think. He gave all the places for up to 118. Till there, whatever the elements are there, he gave a nomenclature for each and every number. For example, 1 it has one name, 2 it has one name, 3 it has one name, like that, right? What is the number did he give is, these are very interesting and very easy to understand. For 1, he gave the name uni, for 2 he gave bi, for 3 he gave tri, and all the thing it has to end with the word um, right? That's how he gave the name, right? Then what about 0? 0 he gave the name as nil. Based on this, for example, see here, if there is an element in future element whose atomic number is 104, 104. What do you mean by the 1? Uni. What is 0? NIL. What is 4? Actually it is quad. EM. Okay. Now tell me the name. Uni nil quadium. Isn't it? Or else let us assume element is some 3. 103. 1 is uni, 0 is nil, 3 is tri. Right? Is it okay? Then the name goes as uni nil trium. Is it clear? That is how he mentioned a particular nomenclature of future elements. I mean future predicting, by predicting the future he gave this kind of name for almost up to some 118 or 120 elements. Is it clear? Fine. And not only that, there were many defects of modern period, Mendeleev periodic table have been corrected by Moseley. And one more thing you have to remember in the modern periodic table is, from the starting of the Mendeleev periodic table, there was no particular specific place for hydrogen atom. Same thing happens here. Here also in Moseley, no one were able to give an exact position of hydrogen. Is it clear? Did you understand? Fine. In the next period, let us look into the construction of this modern periodic table and what are its variations of different properties. Fine. Did you understand? Clear? What all we discussed? We have started our discussion with the need of classifying elements. Then we have jumped into periodic classification. What is periodic table and everything. Right? After that, we have discussed Dobereiner, Newland, Mendeleev, Moseley's different periodic tables. Right? How did they arrange? Right? What is the importance of the periodic table and all such things we have discussed. In the next session, we will start our discussion with the construction or the brief structure explanation of Moseley's periodic table, that is modern periodic table, which is actually depends on atomic number. Right? What are the different blocks in it? How are the elements are arranged? Okay? And what are the different physical and chemical properties which vary? Right? And I forgot to tell, there are few physical properties which you have to remember, that is melting point, boiling point, and those are all particular physical quantities or the physical properties of an atom are being discussed by only person Newland, and few of the properties were also discussed by Mendeleev. Then how are they varied in a periodic table of a Moseley? Is it clear? Fine. Let us meet in the next class with the next topic of periodic classification.